In this topic, we'll explore why certificate validation can suddenly fail, even when the certificate itself looks fine. You'll see how CRL and AIA locations influence trust, and how to use PKIView and Certutil to quickly pinpoint and fix these issues. So far, you've taken PKI from theory into a working Azure-based enterprise CAA, issued real IIS, RDP, user, and computer certificates, and started troubleshooting enrollment and chain issues. Now we'll focus on the next big reliability challenge: CRL and AIA failures. A certificate can be perfectly valid and still be rejected if the client can't follow two key breadcrumbs: CDP and AIA. CDP tells the client where to fetch the CRL to check if the certificate was revoked. If that URL is wrong, blocked, or the CRL is missing, revocation checking fails. AIA tells the client where to get intermediate CA certificates. If that location is unavailable, the chain can't be completed. Either way, you end up with a broken trust path and confusing application errors. When a Windows client receives a certificate, its first job is to build a chain to a root it already trusts. If an intermediate is missing, it follows the AIA URL in the certificate and downloads that issuer certificate. Once the chain is in place, the client checks whether any certificate in that chain has been revoked, using CRLs from CDP locations or OCSP. Any missing certificate or unreachable URL can slow validation significantly or cause it to fail outright. CRL or AIA problems rarely call themselves out directly. Instead, you'll see revocation checks failing, or services like RDP, IIS, or VPN rejecting certificates that appear fine. Event logs will show chain building or revocation errors, and users experience slow logons or connections as clients time out trying to reach unavailable URLs. It's not enough for clients to reach a CRL. That CRL also has to be fresh. Each CRL includes a ThisUpdate and a NextUpdate time. During that window, clients treat the list as valid. Once the current time moves past NextUpdate, Windows treats the revocation status as unknown and may fail validation. That usually points to a CA that stopped publishing, or a broken publishing job, which is why monitoring CRL freshness is so important. When a certificate is validated, the client must download the CRL from the URL in the CDP extension. If that HTTP or LDAP location can't be reached, revocation fails, even though the certificate itself looks fine. In real environments, this means checking firewalls, proxies, DNS, and the web server hosting the CRL. Always test from the failing client. The CA server might reach the URL, while a workgroup or external system cannot. CDP paths are baked into a certificate at the moment it's issued. If the CA was misconfigured that day, every certificate it produced points to the wrong CRL location. Clients follow those bad URLs, hit 404 errors, and treat the revocation check as failed, even if a valid CRL exists somewhere else. Fixing the CA configuration later doesn't repair those existing certificates. They must be renewed or reissued with corrected CDP paths. CRL caching explains why some clients fail while others work. Think of it like a local photocopy of a document. If the CRL distribution point goes down, any client that already cached a valid CRL can keep using that copy and still validate certificates. Another client with no cached CRL has to contact the broken server and fails. That's why CRL issues can appear random. When troubleshooting, test from multiple machines and consider what each client may have cached. When a client receives a certificate, it often doesn't have the full chain locally. It relies on the AIA URL to download the issuer CA certificate, typically over HTTP or LDAP. If those locations are missing, broken, or never published, the client can't complete the chain and validation fails. Domain-joined machines might quietly recover using Active Directory, but non-domain or external clients depend heavily on working HTTP AIA paths for interoperability. Now picture a VPN appliance in a DMZ, not joined to the domain, trying to validate an internal server certificate. The AIA in that certificate points to an LDAP URL or to an HTTP server that's only reachable on the corporate network. From the VPN's perspective, the intermediate CA simply doesn't exist, so the chain is incomplete. The remedy is to publish those CA certificates on a publicly reachable, reliable HTTP location. PKIView is your fast health check for CDP and AIA locations. When you open it, it queries each enterprise CA and shows whether CRLs and CA certificates are reachable and current. Green indicates the publication point is healthy. Yellow or red suggests an expired CRL, a missing CA certificate, or an unreachable URL. Use PKIView to spot issues quickly, then reproduce them from a real client to confirm the actual impact. Certutil's URL option lets you test exactly what the client is trying to reach. Run certutil-url./servercert.cer from the affected machine, not from the CA. It will attempt to download the CRL from CDP URLs, build the chain using AIA URLs, and contact any OCSP responders. Focus on which locations fail and which errors you see, then correlate that with event logs and the certificate's extensions. When CRL or AIA validation fails, follow a repeatable process instead of guessing. Start by inspecting the certificate and reading exactly which CDP and AIA URLs it contains. Then, from the failing client, test each URL so you know whether the problem is reachability or content. Next, check the CA or web server to confirm CRLs and CA certificates are actually published. Finally, republish or correct paths, and reissue certificates only when you truly need to. CRL and AIA Health directly determines whether certificates validate or fail. You've focused on CRL freshness, reachability of URLs, correct CDP and AIA locations, and how missing issuer certificates break chains. Use PKIView and Certutil to catch issues early. Next, we'll look at how to automate and operationalize this work with PowerShell.